Hello, this is David Hilster. I'm a critical thinker, dissident scientist, and if you are not science woke, then this is the place for you. There are literally thousands and thousands of scientists from around the world who've been working outside the mainstream, who have identified problems, fixed those problems, and who are proposing new theories and models. You won't find anything like this on YouTube, so make sure you go down below and click the subscribe button, the little bell next to it, and you'll be alerted to when our next video drops. Hey, ask Ethan from Forbes magazine. Of course, Forbes is where you go to find out about the universe, right? I guess these kinds of articles are written for those people who are millionaires and billionaires who really love science, who never became a scientist, but I guess this is to keep them up to date so they can be intellectuals. What is an intellectual? What does David D. Hilster say an intellectual is? It's a person who wants to look like they're up to date on everything and they're smart. They parrot everything they're told, pretend to understand it, and get into heated discussions about it, not knowing anything. Well, this guy isn't going to help in that discussion because we're going to tear this apart and show you how to become a science woke person, how to read this stuff. And in fact, we have lots and lots of problems. So let's just start. The question is space-time really a fabric? Now, when I read that, I'm thinking, oh my gosh, if it isn't a fabric, he's going to tell me what it is. Well, I've got some news for you. No, he doesn't. Now, he goes off on a tangent here, and this is the interesting part. So he goes through this entire argument, and he talks about, oh, wait a minute, the fabric part, we're not looking at this right. But he never answers the question of what, if it's not a fabric, what is it? So maybe he's true to his title because he just says, well, it isn't a fabric, but he doesn't tell you what it is. In fact, in his own words, he tells you that. So let's read it. It says, in a Newtonian picture of gravity, space and time are absolute. Let's just start with a certain sentence. What does that mean? Space and time are absolute. Does that mean, I guess he's trying to say that they're not together. Yep, space is a place where things are. Time is basically movement. It has to do with movement. Time makes no sense without movement. So as Glenn Borkert often says, time is movement, or at least time is our way to try to measure movement. So absolute fixed quantities. While in the Einsteinian picture, space is a single unified structure where the three dimensions of space and time unified structure where the three dimensions of space and the one dimension of time are intrinsically linked. Let's just look at one word in there. Almost speaking Portuguese there. Linked. What does that mean? I'm talking about, this is physics. The universe is physical. What does it mean to link space and time? I mean, we do it mathematically. But here we're trying to, the average person's like, just tell me what it is. So, I mean, what does that mean? And it also says the unified structure where three dimensions of space, so he's calling it a structure. So it's not a fabric. So now is it a structure? Let's just keep going and see how this guy just goes all over the place. Gravity might have been the first fundamental force ever discovered, but in many ways it remains the least well understood. Even a blind squirrel finds an acorn, as we say in English. Who knows? We know that it's always attractive, and that any two masses in the universe, no matter where they are, will experience its force. Boo. It isn't necessarily attractive. Attractive is the way we look at it. Two bodies are attracted. That's the result of the force of gravity. Remember, I'm your science therapist. I'm trying to get you through this. Don't just read this stuff and blast by it. Every sentence is a exercise, in this case, in double talk, in triple talk. So you got to dissect it and find out. So there you go. It's not attractive. It's a pushing force. Things go together. So that's what we say in the modern world of physics. When Einstein concocted, because he absolutely concocted this, because he didn't go out and discover it, he concocted his general theory of relativity. One of the great advances was to recognize that space and time were combined into a single entity, space-time. So has he told us what it is? Nope. I mean, let's face it, it sounds really impressive. I mean, that's what That's why people talk about it and they write about it. Space-time, the fabric of space-time, the torn fabric. It's in movies all the time. But what is it? We're not saying so far. Another was the presence of matter and energy, an energy curve. Another was that the presence of matter and energy curved the very fabric of the space-time. Okay, now it's a fabric. And that curved space-time, in turn, dictated how matter moved. But is this picture right? And this is his whole thesis of this. I'd like somebody to finally acknowledge and admit that showing balls on a bed sheet doesn't cut it as a picture of reality. I can agree, but let's keep going. I'm not going to dwell on that point. I freely acknowledge and admit it. As ubiquitous as pictures of bench sheets in coordinate systems are, they aren't exactly reflective of the reality we inhabit. Duh. Here, let's look at this in the bottom here. The space-time curvature around a massive object is determined by the combination of mass, distance from the center of the mass. I thought it was fabric of space-time. All right. See? It's very confusing. However, this two-dimensional grid-like depiction of space-time isn't necessarily the most accurate way to perceive it. Okay, first criticism right here. Look at it right here. See it right here? My finger goes right behind it. Now, if you look at that, he's saying that's a two-dimensional. Well, first of all, the whole picture is two-dimensional. Second of all, it's a two-dimensional picture trying to describe a three-dimensional universe. You've got a sun there, you got an earth there, you're assuming those are spheres, and you have the fabric there, the rubber sheet there. Here's where he's wrong in his description. The reason you see shading, I'm an artist, and I draw stuff. I am. Go check it out, DaveDeHilster.com. Check out I'm an artist. When I draw something and I'm drawing like the portrait of my wife, I shade it. Why do I shade it? Because I'm trying to represent 3 dimensions in 2 dimensions. So if you look at this right here, that is a picture of a rubber sheet in 3 dimensions. It's not 2 dimensions. That's why they draw it like that. So I don't know what he's saying. This is a 3-dimensional sheet. Maybe he's saying the sheet has no thickness, but say it. Look at the confusion. Remember, double talk, understanding, don't even know their logic of their own arguments. Let's just keep going. Instead, we can do better by going to the correct number of spatial dimensions. 3. Yeah. Universe only has 3 dimensions. No, time is not a dimension, folks. It ain't. Imagine to start that we have completely empty space. Can't exist. Go watch, right there, go watch the video and listen to the great Dr. Borkett of how you cannot have empty space. There are no masses nearby. There's no radiation. There's no dark energy, no dark matter, no dark energy, no dark... Okay. Ooh. Or anything else that might cause this space to curve. I'm going to shoot myself in the head again. Oh, I hit the wrong button. Boo. Oh, you don't like me shooting myself in the head. Okay, folks, here's the double and triple talk. First of all, I can't have empty space, no such thing. I know you can sit there and imagine stuff in the world, but believe me, nothing functions in the universe without stuff. That's why I've said thought experiments where you try to everything's gone except this can't exist. So here's another thing. No dark matter doesn't exist because we can explain the velocity of the stars without dark matter. Go see it right there. I'm pointing to it up there. Click on it. Dark energy, there's no such thing as energy. Energy is a concept we use. It's a very useful concept. And there's, of course, no neutrinos. No neutrinos. Here we go. Here's another one. Take a look at it. Neutrinos were invented. So basically he said, we have empty space, which we can't have. There's dark matter, which doesn't really exist, or dark energy, which doesn't really exist, and neutrinos, which were invented, which don't really exist. Instead, just imagine space is flat, static, and empty. how can you have space as flat? Didn't you just say it was 3 dimensions? How flat is a thing that has an edge? The universe is infinite, goes on forever. I told you, this is double talk. This is when you can rip apart in 1,000 billion ways. There's just so much wrong here. Instead, we insisted on drawing if we insisted on drawing a grid like a mathematical overlay atop space itself, here's what it would look like. And I'm just going to skip ahead here. Oh, well, I'll show you what it looks like. There it is. Instead of empty space, blank 3D grid, putting mass down causes what it would have been straight lines instead to become curved lines, specific amount. Note that they appear to drag towards rather than away from the mass in question. So is this the fabric of space-time? Is this non-flat space? Well, if it's sort of like those lines, are there lines out there? Oh, if there's not lines, it's what? Space-time? What's space-time? You tell me it's not a fabric. Now what are you telling me? Let's go back. Now let's put the mass down in space-time. The mass has got to curve space-time. You still haven't told me what it is, but it isn't actually a fabric. Oh, it's simply the nothingness that makes up the entity. People read this. Are there people like in billionaires in office buildings like in New York City, in Tokyo, and Moscow, and all over the world, no Brasil, no Rio de Janeiro? Are they all sitting there reading this stuff thinking they're smart? Is that why they write these articles in Forbes? The equations of general relativity tell us how this curvature works geometrically, but they don't tell us how to visualize it. Tells us how this curvature works. Again, okay, so it's curvature? To curve something, you have to have something physical there. So far, still it's not a fabric. He's just going what he's really going to tell us, and he's telling us here. It's not a fabric. It's this like thing with the ball in the middle and the lines. Okay, you can't just do one plane through it. That's only 2 dimensions. No, it's 3-dimensional. It's a 3-dimensional plane. They shade it and everything. One brilliant way to do so, however, is to draw your grid lines as though they represent a force experienced by a negligibly massed, pressure-free dust particle that's at rest with respect to the new mass. The greater, I don't even want to try that. Sorry, folks, I'm not reading well here. The greater the force the particle would experience, the greater the space-time curvature. If we were to draw it out, we derive something very different, more useful. Of course, that's what I was showing you before. Let's keep going. You can talk about space as fabric, but if you do, beware that you are doing it implicitly reducing your perspective down to a 2-dimensional analogy. No! A plane has no height, but the fabric is bent. It's in 3 dimensions. You're cutting out a plane, a 3-dimensional plane. But I guess what, he's trying to come up, you know what the idea. He's trying to make it so, oh, this is a 2-dimensional object because it has no thickness. So are you saying that, okay, so you're saying fabric has no thickness, therefore, I don't know. I'm not even going to try to untangle this. Space in our universe is 3-dimensional, and when you combine it with time, you get a 4-dimensional quantity. You do. It's quantity. It ain't real. When it comes down to the notion of space-time curvature, this is what general relativity refers to. Right, mathematics. But under no circumstance should you conceive of space as though it is a material, physical thing. It isn't. Okay, what is it then? This is the only mathematical structure that we can write down equation to describe. This is only a mathematical structure to write down that equation to describe. The equations of Einstein's general relativity. Okay, I can buy that. It's just equations, it's nothing. The fact that matter and radiation respond to the curvature in exact ways that the equations predict validates this theory, but it doesn't mean that space is actually a fabric. Okay, let's keep going. I can tear apart that, but I will just not. What can we observe? What we can observe, however, are physical objects, the matter and radiation present within space. Of course, space. The radiation what they're talking about there, for you people who want to be science woke, is that gravity bends light. And of course that's been refuted by a NASA scientist in our group who says, hey, when you're outside the corona, there's no bending anymore, even though general relativity's equations and all the space-time tells us it should. But it doesn't. It doesn't curve there. But somehow we ignore that. So what do we critical thinkers and space science woke people say? Mass curves light. Put a stick in water and watch the stick. It looks curved. It's being curved. Water curves light. Coronas curve light. Space-time, which doesn't exist, doesn't curve light. We don't do very well at accepting mathematics for what it is. So we chose to make analogies to help us picture what's happening with the universe. You really want to know what's there? And that math is useless in telling us that? The success of general relativity rises and falls with observations and measurements. Yeah, it does. It fails the test of bending light outside the corona. We can observe the measurable consequences of this theory, but not the actual structure of space-time. It's just math. No, you're calling it structure. You see the double talk and the triple talk and the quadruple talk? I call it quadruple talk because they call 4 dimensions when there's only 3, even if it's predicted by the underlying theory itself. Back again to not answering the question, because when I started reading this as an entrepreneur who's made so much money in life, I just want to be science woke now because I've done everything. I don't have to work ever a day in my life. I'm sitting there reading Forbes, and you're not telling me what space-time really is. It's not. It's a structure. It's just equations. It's predicted. What is it? I'm going to go back to my fabric. Okay, and all analogies in this regard have limitations and flaws. We can choose a visualization that's less wrong, perhaps less wrong than a 2D picture of bent fabric. Okay, it's a 2D picture of the stuff you showed us that's supposed to be 3D. Again, what he should say is that a visualization is wrong. Perhaps that a 3-dimensional picture of bent fabric that's represented in a 2-dimensional photo, but there is no correct answer. General relativity tells us that the universe does given up. General relativity tells us what the universe does given matter and energy distributed in a specific way, and our observations are consistent with it. No, they're not. Okay? That's why they don't listen to that, and this guy will never listen to it because people are entrenched. They don't want to change. We can choose to visualize it in whatever way makes most sense to us, but all visualizations are inherently flawed. The best we can do is try to comprehend the universe, as puzzling as it may be, and as it actually is. This is part of the things that I say. This is part of, if you want to see that they're pulling the wool over our eyes in many ways in other areas of life, like politics and economics and ecology and all those stuff. They're doing it here in science too, because they constantly say that we're trying to comprehend it. It's really complex. It's puzzling, and that's just the way it is. Meaning, we are smart, you are dumb, we're going to pretend to understand all this double talk, triple talk, and quadruple talk, and we're going to make you feel bad for it, and therefore, and you don't believe me? Well, let's just take a look at this. Who wrote this? Oh, send your questions to startingwithabig@gmail.com. Got them so that you can't, And astrophysicist. Astrophysicist is used here to intimidate you, to tell you that I am super brain, that my brain is way bigger than this. It's a virtual brain. It's a four-dimensional space-time brain right here that's bigger than yours, and I have this super intelligence that you don't have. So I'm an astrophysicist. Okay? I have a PhD. I am a PhD, astrophysicist. Is he an astrophysicist? Okay, so he must be right and I must be wrong because of his title, who professes physics in Australia at various colleges. So does that mean that all the colleges that taught way back in the 1500s and 1600s that the Earth was the center of the universe, that made them right? Anyways, folks, the idea of this guy, this whole article, was to show us, let's go back to slide 1, is space-time really a fabric? His main objective here is to show you, no, fabric is a 2-dimension, and we really should be looking in this 3 dimensions. So it's not really a fabric, but it's structure, he says at times. It's only mathematics. It's guaranteed to be there by general relativity, which has been proven right, which we have evidence very contrary to it. So you can see that in general, when you read these, you want to shoot yourself in the head if you are a critical thinker and if you are science woke. If you are not science woke, I've hoped that you guys get something out of this. And remember, as I always say, stay critical, stay thinking. I am Dave D. Hilster. I am your science therapist. I will take you to the science woke paradise of where you will not be buying stuff like this. Ciao for now.